All right, guys. So we're about to finish up this unit with congruent triangles. We're actually on the last lesson here with angle side angle side, and hypotenuse leg. All right. So triangle congruence. We talked about side and side angle side. So we're going to talk about three more today, and then we'll be done with congruent triangles. So another way to prove triangles are congruent are if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So in this one, if angle A is congruent, excuse me, to angle D, and then the side AB is congruent to DE, and then an angle on that same line, so then angle B congruent to angle E, then the triangles, so triangle ABC is congruent to triangle DEF. All right, so notice it all has to be on the one same line. Angle, side, angle. Angle, side, angle on the same one right here. So let's take a look at some sample proofs. Given SQ bisects RQT. So if it bisects it, it cuts the angle in half. So those two angles are now congruent. And it also bisects RST. So this angle, it cuts it into two congruent angles, all right? So what are we trying to prove? We're trying to prove QRS is congruent to QTS, all right? So SQ bisects, that's in that given area, all right? Now, how do we know RQS is congruent to TQS? It's an angle, so that reference sheet that you would have, reasons angles are congruent. If SQ is a bisector, that angle it cuts that angle, that big angle in half. That's a definition of angle bisector. All right. Now, if it also cut this angle in half, that would also be a definition of angle bisector. Now, how do we know that QS is congruent to QS? What was that reasoning? One of the three that are reason sides are congruent. Reflexive property. So now, what is our reasoning? On this line right here, angle, side, angle. Angle, side, angle. A, S, A. All right, let's go to number 2. JK is parallel to LM. So JK parallel to LM. And then JL is parallel to KM. All right, I'm going to put 2 arrows on this one. All right, so how do we know that? Well, that's given. Now, let's see what the next one says. Angle JKL, this angle right here, is congruent to MLK. This one right here. How do we know that? What type of angles are these? Well, we have parallel lines and we have a transversal. They're on alternate sides. So they're alternate interior angles. Okay. Now we have JLK, so the other side of it, and MKL, this side. Again, what type are they? Parallel lines, transversal, alternate sides on the inside, alternate interior angles. KL is congruent to LK, so obviously these triangles share this middle one. which would be the reflexive property. So then number 5, how do we know? Angle, side, angle. All right, number 3, given angle BAC, this angle right here, is congruent to DEC, right there. And C is the midpoint of AE. So if C is the midpoint of AE, that means AC and CE are congruent. We're trying to prove ABC is congruent to triangle EDC. All right, so our statements, angle BAC congruent to angle EC, that's given. C is the midpoint of AE, given. All right, now we know that C is the midpoint, so that means AE was cut in half. What are the two new sides? AC is congruent to CE. And how do we know that for sides? If we have a midpoint, that means the two parts that make up the whole are congruent, so that is a definition of midpoint. Now, we have an angle and a side. Do we have any angles that are possibly vertical or congruent? Yes, right here we have vertical angles. So, angle ACB is congruent to angle ECD by vertical angles. So now what is our reasoning? Angle, side, angle. All right. Now another way that we can prove them is called angle, angle, side. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, the triangles are congruent. So if angle A is congruent to angle D and angle B congruent to angle E and the side BC congruent to EF, then we can say triangle ABC is congruent to triangle DEF. All right? So let's take a look at a couple sample proofs here. All right? Number 4, YZ bisects WYX. So if it bisects it, that means it cuts it in the angles in half. Right there they are. Now, angle WYZ is congruent to angle YWZ right here is congruent to YXZ right here. All right, so we have two angles that we know. So our statement, YZ bisects angle WYX, given. It's right there in the given. Angle YWZ congruent to angle YXZ, given. We don't have any more given, so I'm going to go to the prove. Triangle WYZ is congruent to triangle XYZ. All right, so we're trying to prove that. Now, if YZ bisects these, what are the two new angles created? Angle WYZ would be congruent to angle XYZ. YZ. By what reasoning? Definition of angle bisector. Cuts it in half. Now, do we have a shared side in this triangle? These two triangles? Yes. YZ would be congruent to ZY. And what is our reasoning? One of the reasons in Y sides are congruent is the reflexive property. All right, now how do we know? Angle, angle, side. A, S. All right, we'll do number 5 and call and be done with the angle, angle, side. So given triangle angle ABC is congruent to CED, and AB is parallel to CE, and C is the midpoint of AD. Prove triangle ABC is congruent to triangle CED. All right, our first one, angle ABC congruent to angle CED, given. The next, AB parallel to CE, given. C is the midpoint of AD, also given. So, if C is the midpoint, it cuts AD in half. The two new segments, AC, is congruent to CD. How is that? Definition of midpoint. All right, definition of midpoint. Now, we have an angle and a side. An angle and a side. All we know are that these lines are parallel. So that will tell us something about these angles right here. Angle BAC would be congruent to angle ECD by what? If they're in the same spot on a different transversal in the same location, they are corresponding angles. All right? So then number 6, what is our reason? Angle, angle, side. All right? Good job. We're going to skip 6 and 7. We're going to go to right triangle congruence with hypotenuse leg. So anytime you have a right angle, you are going to use hypotenuse leg, all right? If the hypotenuse, the diagonal, and a leg of one of the right triangles is congruent to a hypotenuse and a leg of another right triangle, then they are congruent. So if BC, the hypotenuse, is congruent to EF, and if a leg, AB, is congruent to a leg, DE, then we can say the triangles ABC are congruent to triangle DEF. All right? The hypotenuse is the side opposite the right angle, the diagonal. The leg is a side adjacent. Okay? So let's take a look. We're just going to do these last two, 1 and 2 here. Given triangle LMP and MNP are right triangles. That means they have a right angle. ML is congruent to MN. All right, so how do we know that? Well, that one's given, and this one is given. Now, we're sharing a side. Which side did the two triangles share? MP. MP congruent to MP by the reflexive property. And now for triangle LMP and NMP is all by HL, hypotenuse leg. All right? Now, number 2, given. These are right triangles. W, V, X. So that means the right angle is right here at V. And Y, Z, X, which means it's right here at Z, the middle letter. WV is congruent to YZ. And X is the midpoint of WY. So that means WX and XY are congruent. Prove. So we're trying to prove triangle WVX is congruent to triangle YZX. Okay? We know that triangle WVX and triangle YZX are right triangles. That's given. WV congruent to YZ given, and X is the midpoint of WY given. All right, so we need number 4. It said that WY was cut in half by a midpoint. So therefore, WX is congruent to YX by what? By definition of midpoint. Okay? And then the last one. So how do we know that the triangles are congruent? Well, it's a right angle, so hypotenuse leg. All right? There you go.